Hello students, welcome back to the another session of our data structure journey. Last video we are completed the linear search. Today we are going to cover the binary search. So binary search means it is a searching, means we want to search an element present inside the list of data. But here what happened, whenever you go for binary search algorithm, we have to use the array or data should be sorted order. It works repeatedly divide the searching interval half until the specified element is not found or interval is the empty. The searching interval half by comparing the target element with the middle value. So why we are searching the middle value? Because by the name binary search, I mean binary search tree is a one type of tree where the data elements, each and every node is left child. For example, this is a binary tree. Here what happened? If you go for searching an element, so what happened? This is the 40, means all the left subtree is less than, and all the element present right subtree is the greater than. So, for example, I enter the value is the 90. So, whenever I start searching from this root, 90 means definitely 90 should be right sub present inside the right subtree. Never, because 40 it is 90, 40 is less than the 90 means all the element present inside the left subtree is 40 less than the 40. So there is no need to search the left subtree right now. For searching element is the 90. So simple, we have to go to the right subtree. Then here 50. Then what happened? We have to search 50 is less than or greater than. It is less than. If it is less than, we have to go to the left subtree. If it is there is no left subtree means we have to search the right subtree. Then right subtree value is the 60. So, whether we have to check the left subtree or right subtree. So what we concluded, whenever we are searching an element and all the element, if it is not less than, it is not present inside the left subtree, it must be present inside the right. So may or may not be. So depend upon the value we are searching. So now why? If you tell that the data is in a binary search tree means if you are go for in order traverse, all the elements are sorted. That is the condition for the binary search tree, is that if you go for the binary search, all the elements should be sorted, because for the binary search tree, in order traverse is sorted data. That's why we have to go for the sorted element. Otherwise, we will not get the correct answer. So next question, where we can apply that binary search algorithm, data structure must be sorted, means all the element must be sorted, and assessing element to data structure must contain a constant time, means each and every element we are assessing with a fixed time. Then only the time complexity is less for the binary search tree. So what are the way or what are the different methods we can implement the binary search tree? There are two methods. First one is the iterative method. Second one is the recursive method. Both the method we can apply the binary search tree. In case of recursive method, we are using the divide and conquer approach. In this case, what we are making, we make the lower bounds. For example, this is the indexing 0, 1, 2, 3, 4, 5, 6, 7. So lower bound is that is the start equal to initialization start value is 0, then last value equal to 7. And we make the flag equal to 0. Reason is that we assume that element is not present. Then we have to repeat these two steps continuously. So first we have to find out the mid. What is the mid? So mid equal to 0 plus 7 divided by 2. What is the value? That is the value 3. 3 means this index is right now we have to consider. So this is our last, this is our, before making it last, if we have to compare the value. So here what happened? If the mid value equal to compare, we have to compare. For example, I enter the value is 25. So here what happened? This is our right now start, this is our last. Now we have to compare with this index 35. We have to compare with this. So it is not equal. Then else if whether this value, whatever value is greater than this value, yes, 35 is greater than value, then we have to make the last equal to mid minus 1. Because if the searching element less than this value, definitely it will be present in this way. Reason is that all the data is sorted order. So we have to make that is the mid equal to mid minus 1. This element is not match means this element onwards it will match. So we have to make this as a last. So what we make the right now start equal to 0, last equal to 2. So if it is 2, then what happened? We have to perform. So now what is the mid? Mid is equal to 0 plus 2 divided by 2, that is 1. So which one? This element we make this element. Now this element we have to make the compare with the value. If it is same, yes, it is same. If it is same, then we have to make the flag equal to 1. Means the element is present. And what is the position? Position equal to mid plus 1. Why? Because indexing starting from 0. So right now what is the mid value? 1. But what is the index? 2. So 1 plus 1. This is 2. So we make the position equal to 2 and we make the element is present. We have to exit. For example, I enter the value is greater than. For example, I enter the value 44. Example, I want to search that is the p value equal to 44. So this is 0, 1, 2, 3, 4, 5, 6, 7. So now what is the mid? Mid is start is 0 plus 7 divided by 2, that is 3. What is the 3? This is the 3. So this element is greater than. No, it is less than. Less than means start equal to start mid plus 1. What is mid? This one. So this is right now start. This is right now last. Then we have to make the mid. Mid means which element? 4 plus 7. 4 plus 7 divided by 2. 11 by 2, that is the 5. So which element? This element. So now we have to make the compare with this element. Yes, this is the same. So what is we concluded? We concluded that this is 44. Now for to searching this element, how much comparison we do? We only compare 2 times. First we compare with this 35, then we compare with the 44. With the 2 comparison, we are already got the value. But if we go for the linear search, first, second, third, fourth, fifth, sixth. So after sixth comparison, we will got the result. But here in this case of binary search, we are only get the result in case of second search. But only requirement is that it should be the sorted order. So let's implement the algorithm. So let us do the programming of our binary search algorithm by iterative way. As we know, binary search we can do the by help of the iterative way as well as the recursive way. So first we are going to cover how to implement by the recursive. So in this case, we include 2 header file, stdio as well as the punyo.h header file. Now we have to write down the function. So here the function we make as the name as the binary search, and the function does not return any value. That's why I make the binary search. Function name is search. The function takes one array. For example, the array is a single array. Then it will take the start, then integer last index, starting index we have to pass. Then what is the searching element? Here we make as a name as a key. So now initialization flag equal to 0 means that we assume that is the element is not present inside the list. Then we have to search. So here what happened? We have to traverse until start is less than the last. So we make the while start is less than equal to last. Then now we have to binary search means divided the entire list into the partition. That's why we make the mid equal to start plus last divided by 2. If the mid value is equal to the searching element or not, that's why we make a is equal to key means if the mid value is searching element, then what we have to do? We have to make the flag equal to 1. Because here we assume flag is a variable to indicate whether the variable is present inside the list or not. Initialization we make as a 0. Then what we make? We make the value as a 1, means the element is present. Then what we make? After that, we have to make the element is present. So %d is present. Then what we have to make? We have to make which value is present. That is the key. Then after that, we have to use the break statement. Why? Reason is that once we got the value, then there is no need to traverse the entire list. If the element is not matched with the mid value, then what we have to make? We have to check whether the mid value is less than key value. If it is less than the key value, here what happened? We have to perform iteration way. That's why we make the start equal to mid plus 1. We make the mid plus 1, else we make the last equal to mid minus 1. Either this side or this side. If it is less than, means it is present from the half of the remaining element. That's why we have to mid plus 1. Otherwise, what happened? We have to make the, it may be between the 0 to the mid minus 1. That's why we make like this. Then we have to perform the iteration till the while is start is not equal to last. Once it's over, then what happens? There is a chances the element is present or may not be present. So for that, we go for if flag equal to 0, it means the element is not present. So simple, we have to write down printf %d is not present. So what we have to write down? We have to write down %d is not present. So this is our binary search function for the iterative way. Now we have to write down the main function. So main function we have to write down integer main. So here we declare an array size of 50 elements. So it can store the maximum 50 elements. Then for the size of array we declare n is a variable. Searching element we make as a key. Then printf, it will ask the user to enter the size of array. How many elements we want to store inside the array, we are going to define it, and we will store at the n. So scanf, which variable we are storing? We are going to store at the n variable. So %n, because symbol used to access the address and we store the value. Once it's done, then what happened? We have to store the value into the array. So for we have to traverse from 0 to n minus 1. So for traversing, we require I is a variable. So for I equal to 0, I less than equal to n minus 1, then I plus plus. So this is the for loop to read the value. So here what happened? We have to ask the user to enter the data into the array. Then we have to scanf. So scanf %d, because we are reading integer, then %a of I. So once this for loop is over, we read the value and store inside the array. For example, we want to print the element, so we can print that is the. So we can write down printf new line array elements are so here we have to use the for loop as well as, and we have to print. So for I equal to 0 index to n minus 1. So I is less than equal to n minus 1. then I plus plus. We have to print the value, print the %d. After printing the element, it will print the go for one tab. Reason is that we want each and every element there should be space. That is the one tab. So we use the AI. So it will print the value present inside the array. Once we print the value, here whenever we go for the binary search, main condition is that the data should be in the sorted array. That's why we have to use any sorting algorithm to sort the data present inside the array. So in this program, we are using the bubble sort, the simplest algorithm, that is the bubble sort. We are using the bubble sort, and the bubble sort, how to perform its operation of sorting operation. I have already make a separate video. I put the description section in the video link. You can go refer this one. So now we have to go for sorting the data. So what we have to do here, we require two loop, inner loop, outer loop. For that's why we require I and J. So we make this one as a, so for I equal to 0 to n minus 1. So I is less than equal to n minus 1. Then I plus plus, this is for number of iteration. Then we make the for j equal to 0 to, here what happened? In case of bubble sort, first largest element go to the its proper location. Second iteration, the second largest element is go to the second last position. Third iteration, third largest. So for each and every iteration, we don't have to go to the end of the list. That is the n minus 1. So we don't require to go. So we can make the I is less than equal to I minus 1, because for each and every iteration the data elements are sorted by the larger element sorted in the last location. That's why we don't require to the go to the n minus 1, then j plus plus. So here what we have to do, if aj plus 1, if aj plus 1 is less than aj, then only we have to perform the swapping. So here we are going to perform the swapping by help of the third variable. Without using third variable, it is also possible, but here we are using the third variable. So for third variable, I declare another variable, that is the temp. So how to do it? So here what happened? Temp equal to aj plus 1, then aj plus 1 equal to aj, j store which value right now? It store the value of temp. So this is the end of if statement. Then end of for, inner for, then end of outer for. So our after that what happened? Our data is already sorted. Once the data is sorted, then what happened? We have call the binary search function. So binary search is the function we call. We pass the array. Then the starting value is 0. Starting index is 0. Last index is the n minus 1. And searching element we store in the key. Then we have to write down the get cs to wait for the one character we enter, return 0, because we make the main function should be return an integer value. So this is the end of our main function. So in this complete program, there are two functions. One is the binary search, second one is the main function. Let's compile the program and run the program. Include spelling mistake. So now, okay, we did not declare what is mid. So mid is integer variable. We have to declare the integer variable. Then no error. Okay, good. If there is no error, so we have to enter the size of array. For example, I enter the size is 5. We have to enter the value then 4, then 9. Okay, array elements are 20 is not present. Means in this program there is no compilation error, but there is a logical error. So why it's showing is not present. It will go to if the mid value printf is present, if %d is not present. Let us check the scanf function. Here what happened, we scan AI for printing the value. Then all the value is printed. Then I equal to 0. I j plus 1 is less than. Then only we are swapping j plus 1 j. Then we use the 0 n minus 1 searching element. Okay. Here what happened? We are not asked the user to enter the searching element and we pass the key value. That's why we got the error message. That is the key value, garbage value. That's why it display that the garbage value is not present. So here we have to write down printf new line. Please enter the searching element. Then we have to scan it. This is key value. Then only we have execute. In each and every program, I just try to do such type of things which is happen to everybody, so that whenever you did the program and you found that this is the error occurs, no, there must be something we are missing. That's why we are not getting the correct answer. So let us run 5. So NT value is 20, then 23, then 45, then 11. So we enter the elements are arbitrary way. This is not sorted. Please enter the element searching element. So we enter the 11. 11 is present. We got the correct result. So let us run the program once again. As I have already told you that whenever we do any program, we have to execute multiple times to check whether the program is running for multiple values. No. So 1, 2, 45, 55, because I enter the size is 10. So here what happened? So this, so let here I enter the searching element is 100, but the array elements are 11, 12, 32, 12, 34, 56, 78, 45, 22, 33. 100 is not present. So output we got, that is the 100 is not present. So the program is executed for the both the element present as well as element is not present. Hope you are able to understand the program thoroughly. Program we have already done it. So let us understand the function, how the function will perform its operation. So here what happened? So here we pass the array, we pass the start, means for example, this is 0, 1, 2, 3, 4, 6, 7. So this is the index. So we start the index 0, we end the last index, that is the 7. Then the key value. For example, I want to search which value? 66. For example, we want to search 66. Then what happened? Integer flag. So here what happened? Flag is store the value of 0. We assume that the element is not present. Then another variable we declare, that is the mid. While start is less than equal to null, means 0 is less than 7. Yes. If it is true, then what happened? This while loop is going to be executed. So first statement, mid equal to start plus last divided by, so 0 plus 7 divided by 2, that is 3. Then if A mid means A3. What is A3? This is the array A. So A3 37. 37 is equal to key. What is the key? Key is 66. So 30, no. If it is not, then it will go to the next line of this. So if A mid means A3 is less than key. Less than key means this is 66. So this is our 35. This is 66. If it is true, then start equal to mid plus 1. What is mid? Mid is 3. So what is start right now? So start initially 0 and last is 7. Now start is mid plus 1. Mid plus 1 means 3 plus 1, 4. So 7. Why? Because this is our middle element. If the element is greater than this value, so unnecessary we are not searching this portion. We now start searching this portion. So we make the start as well as this is our last. So it will go to end. Now this one. Now mid equal to start plus last. What is start right now? 4. Then what is the mid? Mid is 4 plus 7 divided by 2. So what is this? This is 11 by 2, that is 5. So what is 5? 44 is 5. So now A mid is 44. Now 44 we compare with the 66. Because our searching element is 66. 44, 66 is no. Then what happened? This is right now 44. 44 is less than key. Yes. If it is true, then what happened? Start equal to mid plus 1. Mid plus 1. So what is mid? 5. 5 plus 1 means 6. Mid is 5. So 5 plus 1, 6. Go to ending collier, go to starting of start is 6. 6 is less than last is the 7. Yes, it is true. If it is true, then mid is start plus last. Start means 4 plus 7, that is 13 divided by 2, that is 6. So now we compare with the 6. A6 is equal to key. What is A6? A6 is 66. So 66 equal to 66. Yes, we got the value. So now we make the flag equal to 1. Print percent means 66 is present and we have to break. We don't have to go. So this is the way the function is executed. Hope. Let us do the implementation of our binary search algorithm by using the recursive method. We are already know the algorithm. So in this program, we require two header file. That's why I already included the header file. Now we have to define the function. As it is a recursive function, means we have to use the recursive method, means we have to write down a recursive function. That's why the binary search tree function return value, that's the integer value. So we have to write down, that is the first, let me write down the recursive function. So binary search, the name of the function is the binary search, and it returns the integer data type and takes the parameter as a array of elements, then starting index, then last index to know what are the elements present inside the array. Then key is the variable, is the searching element. So this function takes four parameters. First one is the array, then the starting index, last index, as well as the searching element, and it function returns a integer data type. So anyhow, as we know, binary search, we have to, for each and every iteration, we have to divide it by two part by help of the middle. So we have to define a variable, that is the mid value. So now we have to check whether start is less than equal to last or not. If it is true, then only we have to perform the operation. Then what we have to do? We have to first make the mid equal to start plus last divided by 2. So start. So this is the way we got the middle index. Once we get the middle index, then we have to check whether the middle index is equal to key value or not, or searching element or not. If it is searching element, then what happened? we have to return the index, means which position. So we have to return index is as the indexing starting from 0 to n minus 1. So whenever we got the value, the index is mid plus 1. So we have to return this value. Then if middle value is less than key value, means searching element less than value, then what happened? We have to call the function, means here we have to go for the recursive function call, that is the same function name. So better I copy this one function name. Then we have to pass the same array. Only here we have to change the starting point. Starting point is the mid plus 1. Then last is same it is, because we know it is not present first half, because middle value is less than the searching value. If the middle value is searching the key value, means if we divided the array into two parts, then it is not present in first part. It is definitely present in the last part. So last part means we have to starting from mid plus 1 to the last. Then we have to pass the searching element. So this is the way we call the function recursively. So here what happened? If it is false, means we know that the element is present first half. First half means start is same, last is middle minus 1, and searching key. This is the key. So if this condition is false, means if start is not equal to, if start is not less than equal to last, then what happened? Means the element is not present. Means we are already traversed the entire area, but the element is not, we did not found the element. So what we have to return? We have to return 0, because in this program we assume that the element we are defining, we will define that the value is, if it is present, then we make the flag value or any flag value equal to 1, means it is present, otherwise it is not present. So for that, if it is not present, means we return the value is 0. Now we have to go to define the our main function. So integer main, as we know that in binary searching algorithm, it is the minimum condition is that the array elements should be sorted order. But here, whatever we are program we enter, whenever we run the program, at the time user may enter the sorted or may not be. But whenever I am writing the program, here I just write down the sorting algorithm so that the program has sorted the data, then apply the binary search algorithm. It is your choice, you may add or you may not be. This one. So array size is 50. Then n is for the number of element present inside the array. Then we are making one flag equal to 0, means we initialization, that is the element is not present. Then searching element is the key, and traversing all the element we require a variable, that is the I. So these are the variable we require. Then we have to write down printf, please enter the size of array. So here we enter the size of array. Once we enter the size of array, then we have to scan the size. So where we are going to store? The variable name is n. So we store the size of array inside the variable, that is the n. Now we have to read the data to the array. So for that we have to write down for I equal to 0, I less than equal to n minus 1, then I plus plus. Then here we have to ask the user enter the element. Please enter data into Then we have to use the scanf to read the value, %d because integer data type, ampersand AI. So we read the value and store inside the array. Then after that, what happened? We have to print the value. For example, we want to print the value. So how to do the print the value? So we can go for printf. For example, two new line will be created. Then only the data will be printed. So two line, the array elements means are. So after that, what happened? New line will be created. Then only the output will be print. So here what happened? We have to use the for loop to print the data. For I equal to 0, I less than equal to n minus 1. We have to traverse the entire loop and we have to print the value. Then printf new line %d. No need to go for direct it will print because already here we mentioned the new line. So after each and every element there should be a one tab space, then ei. So now we read the value, we print the value of array, then we have to ask the user to enter the searching element. Printf new line, please enter the data to be searched. Then we have to scanf %d. Here we use the searching element in the key value. Key is the variable which stores the searching element. Now, here what happened? Flag is the variable which returns the initialization the value 0, and whenever we call the function returns value is integer value. So now whatever the function return, for example, we are going to store inside the temp variable. So now flag equal to the function, here the function right now the recursive function we call. So we pass the array, then indexing 0 to n minus 1, then searching element we store inside the keys we call. After that, we have to check if flag equal to 0, it means that element is not present. So we can write down printf new line %d is not present. It not present. That is else. Printf new line %d is present. That is key. Then this is the our program almost completed. Then we go for get sys, then return 0. Okay. Let us compile the program and run the program. Okay. Here we can put the one tab also. Enter the element 1, 2, 3. Here I enter the data arbitrarily, not any sequential. So array elements are showing list as well. Now what happened? We are using the searching element, that is, for example, I enter the searching element is 11. Right now, just see, 11 is already present, but we are getting the result that is 11 is not present. Can you tell me why? Reason is that for the binary search, the minimum condition is that the element should be sorted. But in this program, till now, we are not sorted. We direct enter into the unsorted data. That's why the element is present, but we got the result that the element is not present. For that, before calling the binary search function, here what happened? We have to use the any sorting algorithm to sort the data present inside the array. After that, we have to go for the sorting algorithm. So here what happened? As we know, for the bubble sort, here I use the bubble sort for sorting the data. We require two loop. For that, I will go for the two variable I and j. So for bubble sort, what is a bubble sort? How the bubble sort is a perform its operation? All the details I have already explained in our previous video. In description section, I just put the link so that you can refer it. Let us write down the code for the bubble sort. You can put the bubble sort algorithm in the separate function and you call it here. It can be possible, but I just make here right now. I am not going to make more complication. So just here it is n minus 1, then I plus plus. This is our outer full means number of iteration we have to perform. Then we know that first iteration, it will store the first largest value at its proper location. Then it will store the second location, so on. That's why for J loop, we don't have to go to the n minus 1. No need to go because for each and every iteration, the number of counting will be decreased by 1. So if a j plus 1 is less than a j-lith element, then what we have to do? Then only we have to go for swapping. So here we are performing the swapping by help of the third variable. So for that I use the temp is variable. So what we have to do is here temp equal to a j plus 1, then j plus 1. All the details I have already explained in our previous video of bubble set. In description section I also put, so don't worry about it. Then aj equal to temp. Then for loop is over. So if it is, then for loop is over. So here what happened? We can write down after sorting the what will be the data. Here please enter the data. Array elements are here. We print the array elements are before sorting. We can write down sorting before sorting. Then after sorting, we can for that it is easy to know whether we are sorting algorithm is done or not. Means for our programming point of view, it is easy for us to find out where is the logical error. That's why I make the data to be printed after the sorting. So let's compile. Okay, here we have to make one tab. No need to go further because same thing we are doing multiple times. Again, we compile the program. Okay, for example, I enter the size is 510. Okay, after sorting means before that the searching element we enter. Okay, no problem. So I just write down 12. So before asking about the searching element, here I just mentioned the only we have to change the sequence of order. Then array element sorted at that 12. then it will let, that's right. Now we got the result or not? Previously we are not able to got the correct result. Please before, please, and then research. Before sorting, okay, this is the way. Okay, we can write them after that, then it will be looks good. After sorting, okay. Only just sequence we change it. For example, I enter 10 element, we have to enter. So now the array elements are before sorting, array elements are after sorting. Yes, it is done. Then it will ask us what is the searching element. For example, I enter the searching element 100. 100 is not present. So now we are getting the correct answer. So it is our choice whether we want to put the array element before sorting, after sorting. I just write down in the code because so that whenever any means any logical error, I can able to trace it. It is your choice. You may add or you may not add. And this is the complete program of binary search using the recursive way. Here the same logic we are apply for the iterative method. Only difference is that whenever we call the function, here what happened? Binary search, here in case of iterative, we make the void as well as while loop to perform the iterative operation. But here what happened? Condition was same. Start is less than equal to last. For in case of iterative, we make as a while statement. Here we make as a if condition because it we have to perform iteratively. So if it is true, mid is equal to start plus last divided by 2. If it is equal to, then we have to return the position. That's why we make the mid plus 1 because indexing starting from 0 to n minus 1. That's why mid plus 1. If it is less than, then what happened? Here we call the same function, that is the binary search function, and we pass the mid plus 1. Why mid plus 1? Because the value is less than, the mid index value is less than the key, means it will definitely present the second half of the array. That's why we make the, so we change the start point. But here if it is a greater than, means it is first half. That's why we make the start as well as the, we change the last index value. This is the way we are performing the recursive method. So this is our main function. Hope you are able to understand the concept. If you have any doubts, you can ask me in the comment section. Definitely, I will help try to solve the problem. So what is the time complexity? In case of binary search, the best case scenario occurs to if whenever we searching an animal, we found first occurrence, means first element. Whenever we make a comparison, first comparison, we will got the value. Then it is the best time complexity, and it is for the binary search. It is order of 1. Average case is the order of log n because each and every iteration, the number of comparison is divided by 2. That's why the average time complexity is order of log n, which is comparative to the linear search, that is the order of n square. That's why the time complexity of binary search is 2 less compared to the linear search. In case of worst case, it is order of log n. So next we have to know what is the advantage of binary search. So first advantage is time complexity is order of n log n, which is much faster than the linear search for the big data set when the data set is sorted for. So this type of searching algorithm is very effective whenever data set is more. Only the condition is that the data should be in sorted order. So it takes the full advantage of the sorted data. If the data is sorted, then binary search can able to take the full advantage. Next one is the disadvantage of binary search algorithm. Main problem with that, whenever we go for the extract the to go for the sorting the time, it required the data should be sorted before the application of the algorithm, because in our implementation phase we are already saw it. Whenever the data is not sorted, the element was present, but we got the result, element was not present. That's why whenever we go for binary search, it is compulsory that we have to require the data to be sorted. For that, we require extra time. And it is more complex whenever we are go for the recursive implementation. If we go the iterative implementation, it is easy, but whenever we go for the recursive implementation, it is very complicated. And whenever data is not in sorted order and the data elements are added and removed very frequently, at that time what happened, we have to perform each and every time. Whenever data is added, we have to sort them. Whenever data is removed, at the time again we have to go to sort the data, because for binary search algorithm, main condition is the data should be sorted. So this is the main drawback of the binary search algorithm in. And here the space complexity is order of log n, which is due to the because whenever you go for the recursive call, what happened for each and every call, the value is the element stored inside the stack space. So in case of binary search, stack space is requirements is more. This is the another advantage of the binary search algorithm. So this is the time complexity comparison between the linear search, binary search. Best case, both are same. Average case, linear search is the order of n, whereas the binary search is order of log n. Worst case also same thing. So this is the for the time complexity. Let's go back to the space complexity. For linear search, it is order of 1. For binary search, it is order of 1. If you go for the iterative, but if we go for the recursive, it is order of log n. Main thing is the for the recursive call, and it's require the stack space. That's why the time space consumption complexity is more in case of binary search if we go for the recursive way. Thanks for watching the video. Subscribe the channel as well as the like the channel, share the channel. Thank you so much.